are usually used when you're given a value of an angle. So let's say you're given sine is, let's do this. 2/3. Is that a unit circle value?
Yeah.
No, it's not. Okay, so there's a value that's not on the unit circle. And gas tanks are on dry, sorry. Okay. Here's how it'll be phrased. And theta has its terminal side. In the first quadrant.
And coterminal is the opposite side.
So what that's telling you is that you're working in quadrant 1. Which is nice because everything's positive. Right? Makes it easy. You might be asked to calculate sine 2 theta. Double the angle, right? We just don't know the angle. But again, as you've seen, we're working with values that are not in the unit circle, both coordinates and angles. Okay, so what is the identity for sine 2 theta? That's basically what you're up against. Okay. There is one, it is two sine theta cosine theta. So you have to use that identity. We know sine theta, right?
Yeah.
2/3. So we can just plug that in. We know cosine theta.
It's down to 3/2, right? No, that's
We're gonna have to figure that out given.
no.
There's a couple different ways. Sine is opposite over hypotenuse, correct?
Yeah.
Can you figure out cosine?
That's what Jason.
Yeah, we just need to know that value, right? So how can we find that value? There you go. X squared is what? Correct? Sorry, what'd you say?
Oh no, I was asking if the letter in the triangle would be.
Theta,
Oh, okay, that's okay.
kind of, looks like a gangster.
I know, I was like, we're just okay.
There you go.
Thank you. Yeah, it was good.
Alright, so what's the value of cosine?
Square root of 5.
Over
3.
Okay, so we plug that in there, and we can plug 2/3 in the other one. So sine at 2 theta is? My calculator is wrong. It's this one, it's wrong. bells? 4 root 5. 2 times 2 is 4. Maybe I should just go hang out with Miss Magruder in math 1. That's how you use double angle identities.
And that's all it is.
Pretty much, that's the method. Okay. Keep in mind, we don't know what the angle is, but we don't need to know it. Okay. There are 4 others. Cosine has 3 different double angle identities you can use. There's one of them. Don't confuse it with the Pythagorean identity. It's not plus, it's minus. There's another one. Different, but can still be useful. If you only know cosine, there you go. You can also do this. That one's also handy if you only know sine. So you can use any single one of those if you wish. They all give you the same answer.
On my calculator, I tried plugging in sine 2 theta and it says it's 0.
Probably because you put the 0
You put theta in.
Theta is so that
Theta is defined as 0 on your calculator right now. So sine of 0 is.
well, how do I change it?
Put the letter in the screen, store, and put a number. Tangent has one as well. Of course, it's kind of messy.
When is tangent ever used?
Why is tangent always messy?
No, I said when is it ever used?
Oh, yeah. That's what happens when you have division problems. Sine over cosine causes issues. Okay, there's your tangent identity.
Okay, why don't you go back to some picture?
So double angle identities use, you're given non-unit circle coordinate. Okay. That's the key. And we're using it to find something else.
No.
I'll be honest with you, those aren't used very often.
If you're
Okay.
Again, the value here, using your unit circle knowledge, practicing processes. Half angle identities are used. You have your unit circles?
Yeah.
Okay, pull them out.
That's how you go away.
Okay, is there an angle on the unit circle where you divide it by 2, take half of the angle, and then half of the angle is not on the unit circle?
Yeah? No, yeah, 45.
30.
180.
Okay, 30.
180.
30 degrees is on the unit circle, right? Half of 30 is not on the unit circle. We can use a half angle identity to calculate the values at 15 degrees. We can also use the sum and difference identities. We've been practicing that, right?
I'm so confused.
So if you want to calculate something like the sine of 15 degrees, that's not on the unit circle, correct?
Right.
Okay. You've already done something like this. Yeah?
Yeah.
Okay. Still possibility. Sum and difference. But we can also do a half angle identity. Are those the same thing?
Yeah.
Yeah, they are. So here's another option. And there are angles that you cannot use this for. Okay. So 15 is one you have options, but there are some that you don't. There's the half angle identity for sine. Right. So this is the key. Right? Half of 30. So 30 is our reference angle we're using here. And that is the formula for half angle, sine half angle.
And you would stop there.
1 minus cosine of
But we have to actually figure it out. Welcome back. Yeah, I know you're having a really good dream. Don't trip over your shades.
Exactly like before.
What's cosine at 30?
Cosine of what?
30 degrees. Quick!
Cosine of
Yeah, you lose.
I'm busy taking notes.
So you see that very similar calculations to what we've been doing. You have some fractions to deal with, right? You're going to have to get common denominators here to simplify this.
What does that say? You see?
You know what? If you were awake, you would know.
Does that make it copy that? Page 4 minus 2.
Yeah. Okay. Positive or negative? All right, I'll let you copy that down, then I'll ask that again.
Yes.
Okay, so the last thing you want to deal with is we have to choose positive or negative.
Oh, it's negative because it's minus 45 minus 30.
15 degrees, sine at 15 degrees. Positive or negative?
Positive?
Because it's in quadrant 1.
Right.
Oh,
Right?
and that's a big note, okay.
Oh, sweet. So now this-
Positive. So look at your original angle. Is sine positive or negative in that quadrant? Okay, so in quadrant 1, sine's positive, so your final answer. Positive.
You mean over 4?
Nope, I don't, actually. Because I can square root 4. 4 is in the root. Okay, so be careful on what's inside the root and what's not. This whole thing's inside here, so if I square root 4, I can take it out, but not until then. Let's see here. The cosine half angle identity is very similar. What's the difference? Compare and contrast the two formulas. One's in black and one's red on it. Nice.
Why are we using both?
One has that.
All those additions.
That's the only difference. So don't mix the two up. Sine half angle identity does use cosine in it. The cosine half angle identity also uses cosine in it. Okay. Okay. Calculate. Here's yours. The value of cosine is 67.5 degrees. Again, you're looking on the unit circle.
67.5.
Is there half of an angle on the unit circle that makes 67.5?
No, so we're screwed.
Chris, you having a rough day?
Isn't it 135?
So it'd be like right here.
Because you can like straighten it up, or we can have issues.
Yeah.
It's 135.
You see it?
Yeah.
There's a group up here that has the number. How about back there? Sierra, do you have it? What is it? Yeah. So 135 divided by 2. So what do you plug into the formula?
1 plus plus or minus root 1 plus cosine over and 1 plus
Yeah,
cosine.
use 135 in the formula. Ready, set, go.
So it's negative root 2 over 2 that you plug in?
Yes.
It'll be 1 minus.
If it's over 2, do you just,
Just do the math, do the arithmetic. Quit acting helpless.
We are helpless.
No, you're not.
I mean,
I'm feeling crappy too, but we're still here working hard.
We're trying.
Did I write this?
How is it hard to
I have no idea.
Right, yes. So the formula says 1 plus
Cosine.
negative root 2 over 2.
That's the out
You
here.
use your unit circle.
You change the sign based on quadrant out here.
Okay.
And there it stays positive since it's cosine. It'll be negative out there.
I think I did see that. What did you do with the, like, the root? Like,
Kind of messy, huh?
so what do you do?
Just leave it. Like I did up there. See, I have a root in
Oh,
there.
yeah.
Just leave it. There's nothing you can do with it without a calculator.
Was cosine negative?
And then.
You all right?
I'll try to take this.
You got the cosine of 30.
I got root 1 plus root 2.
So we'll be fine.
Like we learned yesterday.
I really just follow the same steps.
Could be right.
You know how to do this.
Because you have to,
Oh,
And-
see how back here, you change cosine to
was a sine of 130. 130 is right.
cosine this far, and then you just
Oh, yeah.
actually.
Oh, copy that.
You're right. So it's, well, no, that just makes the outside part of it.
Mr. Arthur,
That just makes the outside part of it.
I'm actually.
I got negative.
I got a sine issue.
But that's what it ends up doing.
No, you have.
Zach.
No lactose, no lactose.
No. When did that happen? Right now?
They're not allowed to trade until March 13th.
Wait, who's leaving where?
No lactose, no lactose.
Is that right?
Yeah.
That's, wait.
I hate that. I'll watch the AFA for the rest of my life.
Start.
Oh, yeah.
It doesn't trade place for the AFA.
Really?
Whatever the heck it is. They keep
You
putting
said hit on that cord right there?
Oh, I got that one.
100%.
I'm so proud of myself.
Pass interference in any other.
Dylan,
I'm so
he
proud
plays
of
for Salt Lake or
myself.
San Diego.
Yeah, that kid from Rifle plays for San Diego.
Wait, what's the,
So then what you do here that you do.
And
what is the 2 and 1?
is it positive or negative?
Negative.
positive.
Yeah, we messed up.
It's negative.
It'd be positive if it's in quadrant.
Again,
135.
Wait, why
Oh,
is it?
Yeah, because,
that's where it's.
think about it.
what quadrant is that in?
Oh, you're right.
Yeah, quadrant 1, cosine is
Oh, I was looking
positive.
for 135.
Oh, I was too.
Yeah, that's the big thing you have to be cautious about. You're not evaluating for 135. You want your final answer to represent this angle here. You're using 135 to find that out, but this has to be what your positive
Wait,
is.
why'd you change it minus to, from plus to minus?
What?
On the inside.
The cosine.
Oh, why is this minus root 2 over 2?
Yeah.
Yeah,
Yeah.
Because it's a negative.
Cosine at 135
it's negative.
is negative root 2 over 2.
That makes sense, okay.
This should have been my first thought.
Then the cosine.
We can fix it up already.
Is that cleared up?
Like, why is it? Yeah, why is it 2 minus? Why is it 2 minus 5? Did I write the formula down wrong?
No, this is a common denominator issue.
No, the, in front of it.
What?
You're wrong.
Why is this 2?
Yeah,
Because I had a common denominator here. 2 over 2,
yeah.
1 is 2 over 2, so now I can write it as a common denominator.
Oh,
Yeah, again, you work your fractions knowledge as much here as anything else.
Yeah.
Here's your tangent.
I've never really seen it.
It's built right from sine over cosine. Sine is,
Sine is.
and cosine. After you copy dot flip, the divide by 2's disappear. It's built directly from sine over cosine. Okay.
you can push that.
Yeah, we're done. Are you guys good with that?
Sure.
You can push it off.
This is the least used section. Okay.
This is like.
It's useful once in a while, but it is the least used section that we have
No, I won't.
in this chapter. Let's see here. Tomorrow, we're gonna play a game of just practicing your identities. And then we'll solve trig functions for a couple days and we'll be done. Yeah, that's what. Me? No, I'm heartless. Do I buy a crush? No, they don't deliver to Grand River Health, so
That's rough.
that would be kind of in poor taste.
Remember to yourself and respect what you said.
Although it would be fun to kind of mess with some of you.
No, that's not cool.
Is that 21.5?
Please
Do it by Tyler Miller a crush,
Please do it.
right?
Yeah, it is girlfriend getting in mine.
Okay, 44.
I don't know why you started.
Add 41 on there, I missed it. 44 has degrees, minutes, seconds. I translated it to decimal degrees for you.
Oh, thank you, that was very
But
nice.
I will say this, having winter survival training on my mind, because we're planning a trip, knowing degrees, minutes, seconds can be very handy in a survival situation where you're reading maps.
Kids that play baseball want to be able to make that.
Okay? But again, most GPSs now translate everything to decimals, so there's some give and take there. I thought we scheduled that for, are you guys gonna have any games?
Our first baseball game's on the 8th. I just looked at the schedule this morning.